Hello, everyone. Welcome to EDA Summit 2023 and welcome to my talk. And today I'm going to talk a little bit about an evaluation that I recently did and where I compared different event brokers, and I will explain why Solace stands out at the end. And eventually, we went for Solace to be the enterprise event broker. So I'll explain why that is the case. Before we get into the real part of today's topic, I'll introduce myself a little bit. My name is Fugu Wei, and I've been working as a principal integration architect at CloudWorks here in Australia. And you can find me on LinkedIn. There's also my email address in case you have any questions for me later. I've been working in the IT sort of industry for almost 2 decades. And I started off as a software developer. Then in the recent 10 years, I sort of, have been quite active and in the integration space and really passionate about EDA-based applications, and love event brokers, love to learn new stuff about brokers. So this is the agenda for today. There are essentially 3 things I'm going to go through. I'll start off with a problem statement where I'll highlight a problem that I was looking into, why I went to that evaluation journey. So what was a problem that we were trying to solve behind the scene. And then we will speak about 3 different types of event brokers: queue-based, log-based, and subscription-based. I'll talk about the characteristics of each type of broker. Then we will look at particularly 4 brokers there, and do a bit of comparison between 4 different brokers: AWS EventBridge, Anypoint MQ, and Kafka, and Solace PubSub Plus. So these were the 4 brokers that I compared during my evaluation. I'll look at the comparison from different perspectives and give you a bit of insights into these brokers. And finally, we will draw a conclusion, as I explained, that we'll talk about why the pros and cons of each broker, and then why Solace stood out at the end to be the choice. So this is a sort of fictional story there I made up, but it's close enough to a real problem in reality. So there was a large retailer, and they saw a big growth in their online orders in the past few years. Obviously, that's due to the shift of the paradigm of more shoppers shopping online, particularly after the pandemic began. So the shoppers, would do online for either home delivery or click and collect. They still go to stores, but they order online and go to stores and pick it up and their order. And in November 2021, during the peak trade, Black Friday and Cyber Monday, there was a network outage occurred in the IT system of this retailer. That outage lasted for about 2 hours. And during that time, the online orders stacked up quite rapidly. As I said, they were seeing like hundreds and thousands of orders, online in a minute. So it's quite a lot of orders stacked up in their middleware queue. And when the network was restored later, they started to replay the orders from the queue. Because of the legacy queue system they had, it was really slow to replay. Like one order took about 5 seconds to replay. And they could make it quicker, but that would require a code change, a lot of customization. So that actually basically violated a lot of their SLAs. For instance, they had this 20-minute SLA for click and collect orders. So when you book, when you make a purchase online, and you can drive to a store to pick your order up within 20 minutes. That was their SLA, but obviously due to this outage and then also the slowness of the queuing system in the middleware exacerbated the issue there. So they ended up a lot of unhappy customers there. So the retailer then went ahead to the market to search for an enterprise level event broker to fulfill two key requirements there. First one is high performing. They want an event broker that can process large throughput, like thousands of messages per second, if possible. And the second key requirement there was high resilience. And so they want an event broker to be able to allow them to replay messages efficiently and effectively without much customization, if possible. So at the same time, they also had a number of new requirements coming from their future projects, because they were doing quite a bit digital transformation sort of journey there. And they wanted the future event broker to fulfill the following requirements at the same time. So it's got to be a true EDA broker, where their event designers can design their topic hierarchies or event schemas, using an editor, some sort of editor, as part of that broker offering, if that can be a feature, a desirable feature. And then they want the broker to guarantee the message ordering, which is critical for them because, for instance, for their orders, they want to make sure that the orders are processed in the sequence that they are arrived and they are received. For instance, if an order is received first, that order needs to get processed before any newer orders. So then they want the event broker to support multiple different protocols, because the direction they're heading off to is they're gonna have a lot of event subscribers in the future, and these subscriber systems will be based on different technology stacks, and they would use different protocols. Some of them may do REST API calls, some of them may do JMS, some of them may do MQTT, and particularly they would have a lot of IoT sort of devices coming along. So you want this event broker to prepare them for the future. The content-based subscription is another feature they wanted to have, where they want to be able to filter out messages based on certain parameters within the content. And for instance, it could be, give me all the orders that were created by the customers in Sydney region, for example. And they want the messages to be encrypted at rest when they are on a broker. So before we look into the comparison, which I did among these 4 brokers that I mentioned just now, let's have a look at these 3 types of event brokers, what the characteristics are among them. And we'll start off with a queue-based event broker. The idea of queue-based event broker is that, when you publish a message into an event broker, for every subscriber system, there's going to be a queue created for it. So yeah, as the name suggests, obviously queue-based broker would support integration patterns like PubSub, where you can, fan out. You can have multiple queues and one queue for each subscriber, as I said. And at the same time, it can support, point-to-point, queue-based integration pattern, like the second diagram there shows. And then the third diagram there actually shows it's a variant of a queue, point-to-point queue-based integration pattern where event publisher is actually getting a response immediately from the event subscriber synchronously. But through the messages are still going through event broker there. Some of the examples, like a lot of them you have heard of, I believe, like Anypoint MQ, for instance, that's a Mulesoft product. It's actually based on Amazon SQS, and there's SQS. Then there's Solace PubSub. Solace PubSub actually falls into this category. It's a queue-based event broker. This sort of broker is recommended if you want to have multiple protocol support, as I explained earlier on, where you want to have JMS protocol for a particular subscriber system, or a REST API, and etc. etc. And you want to have hierarchical topic structures, and you would go for this type of broker. Then there's second type of broker. It's called log-based. The famous one, obviously, a lot of you guys probably have heard of it. It's Kafka. The idea of a log-based broker is that every new message published, it goes into a read-only log. So it actually the event broker would append the messages to the log. So it's a log file, essentially. You keep appending new messages, and the subscribers, when they subscribe a topic, they actually pull the message from the log, and the subscriber needs to maintain a concept called offset, which is the location of the message that they need to subscribe from that topic. So every time when a message is successfully consumed by a subscriber, they need to move the offset to the next position. So a log-based event broker, nobody's going to delete the messages, unlike the queue-based, where when a message is consumed and a message actually is deleted off from the queue. But log-based broker, on contrast, is that the logs would be there, and the messages will be there in the log, and unless you set a retention period, or if the system runs out of space, or start to delete the older messages first. Some of the examples, like Kafka, as I mentioned, in fact, there's different variants of Kafka. Confluent, for instance, is built on top of Kafka, and Amazon Kinesis is another one. And yeah, the big highlight of log-based brokers is they are very fast. Obviously, as you would understand, it's keep appending. It's about keep appending then messages to the log, and then move the locations of the message for every subscriber. So it's incredibly efficient. Then the next one is a subscription-based brokers, and this is a result of the recent, well, it's probably no longer recent, but it's the cloud adoption and the popularity of a lot of serverless computing architecture, like Lambda functions, for example. And yeah, so when the one idea, when you want to do an EDA-based application in the cloud, like Amazon Cloud or Azure Cloud, you could write a simple Lambda function to respond to an event, like, for instance, a new object in an S3 bucket. That may work for a simple scenario like that, but in reality, there could be complex scenarios where you have multiple different subscriber systems that need to respond to an event. And of course, you could say that you can use SQS, but the idea of SQS in Amazon world is that you have to poll the message. So you want to have a broker that can quickly push the messages to the subscribers in a sort of PubSub fashion, and very quickly and efficiently. So that's why subscription-based brokers were invented. As I said, it's invented for serverless computing. And And it's similar to queue-based brokers, but the major difference is that they don't actually guarantee the ordering of messages. So it's like messages get fired and published and then pushed to the subscribers. That's it. And the broker is not responsible for ensuring the messages are in order, in the right order, according to the sequence where they were published. Some of the examples like EventBridge, that's a typical one. I've been using EventBridge a lot lately. We have been designing some serverless solutions using Lambda functions and on AWS. So this kind of broker is recommended if you don't mind, or if you have your solutions all in one single cloud provider like AWS or Azure. Everything works perfectly there. And a lot of times this kind of event broker is used for notifications or pushing logs entries to for instance to CloudWatch. And of course they have been expanding. When I say they, I mean like AWS EventBridge or Azure EventGrid. They have been expanding their capabilities to support some of third-party partners to tap into their their event broker. Like for instance, you can publish a Salesforce platform event to EventBridge quite easily using the feature called Event Relay onto EventBridge. And then you can also have a lot of SaaS solutions as the target for a message. And the key element of of this type of broker is that for every subscription, you set up a rule. So a rule can be an event pattern based. Essentially it's a regex where you define, if a message matches this criterion, for example, please push this message to this particular target, like a Lambda function behind it. So that's the idea. Now, I've got a slide here, but I think I've gone through the detail of each type of broker, queue-based, log-based, and subscription-based. I'll have it here for you guys to have a read later if you're interested a little bit in detail. But I'm now gonna go to the actual evaluation that I did, and a comparison among the 4 brokers I mentioned: EventBridge, Kafka. EventBridge is a subscription-based broker, as I just explained the characteristics of that type of broker. Kafka is a log-based, Anypoint MQ and PubSub. These 2 brokers are queue-based. So I compared these 4 brokers from various perspectives. Like, we'll start with Event Replay, because this is, as I said, the retailer was after 2 major requirements. One was the performance, high-performing broker, and the second one was a resiliency there. So a key part of that resiliency is that the broker needs to have a flexible event replay feature built in. So when it comes to event replay, EventBridge does support that. In fact, that's actually a newly released feature. It's called Event Archive and Replay. Essentially, you can archive every single message that is published to the event broker on EventBridge, and then later you can choose to replay, given a time frame, for example. But you cannot replay a particular message. For example, I want to replay an order message that it's got an order number 0001. You cannot do that on EventBridge. Kafka does support that. Obviously, it's actually offset based. As long as you can find the right location, the offset, you would be able to replay message from that point, of time. So the way you do it is you can actually query an offset, i.e. the location, by a timestamp. So yeah, so that's how you do it. How you do event replay, because all the logs actually are maintained on a log file, as I explained just now. It does require a bit of coding, and you have to query that. You have to search, find the right location. Again, you cannot replay a particular message out of box. Anypoint MQ doesn't have out-of-box replay feature. The idea of Anypoint MQ is you move messages to DLQ if they fail, but then you have to build code to move the messages out of DLQ for replay. So that all has to be customized and programmed. And Solace PubSub, it supports event replay through a concept called event logs. And so when you set the event, when you enable the event logs, so all the events would go to the event logs will be kept there, and you can replay then any message or any particular messages within a time frame. If you give a time frame there, you can replay the message onto a queue or onto a topic endpoint. And specific messages can also be played through replaying the messages from the replay log. First of all, that's where the messages are kept. Then you can set, what you can do is you can do it smartly with subscription. In Solace, you can define a subscription based on a queue-based or a topic endpoint, where you can set the rule based on topic hierarchy. And so if you want to replay a particular message, you just need to make sure that the topic hierarchy with wildcards based sort of the filtering criteria to make sure that you can play a particular message. For instance, if you were to play all the orders coming from a particular region, you just make sure that region is part of that topic hierarchy criteria for that particular subscription. So then you can replay the messages from the logs to that particular subscription. And next one is message throughput. Among these four brokers, Kafka stands out because yes, it's really high performing for an average 1 kilobyte payload, and the throughput that Kafka was able to deal with was 605,000 transactions per second, according to the report. Here I've got that link there, and there's, of course, there's a detailed hardware sort of set up for that test. And for Solace, it was about 140,000 transactions per second. This is the stats published by Solace, so it's on the Solace website. You can find it there. So these two brokers were both high performing compared to the other two. Obviously, Kafka is the number one when it comes to performance. Multiple protocols support, and Anypoint MQ is the one that supports the least protocol. It only supports REST, and Kafka has its own sort of custom protocol there on top of TCP/IP for communication. That's probably why Kafka is really fast. And whereas the other brokers, they support multiple protocols like REST, JMS, particularly PubSub. Solace PubSub supports multiple protocols like JMS, MQTT, AMQP. That ticks the box. So here comes to my conclusion. So eventually, we went for Solace. It was the winner because the following features. Obviously, I have given the detailed breakdown of the various perspectives. But in summary, Solace won because we actually went for the SaaS offering, which is we've got a control plane and a data plane. And Solace has flexible deployment models where we could choose to deploy Solace on-prem, for data security concern. And so in fact, that's the data plane. So it's the runtime, the broker engines can be hosted on-prem. You can also choose to host it on a VPC of your cloud, like AWS or Azure. And you can also go for the Solace public offering, which is event brokers hosted in their cloud. So that's very flexible. It ticks all the boxes, being an enterprise grade and an event broker. It has best of the both worlds, and it being in queue-based event broker, but at the same time it's high performing. Well, it's relatively high performing still compared to Anypoint MQ and EventBridge. And it's relatively easy to develop client applications for both message publishers as well as the message subscribers. It's got all the different types of protocols and connectors in place so one can use their preferred programming languages to develop these client applications quite easily. It's got great support from the Solace team. This is really to compare the other two, as you can see here. Well, Anypoint MQ I don't mention it here because it's not really enterprise grade. EventBridge, I would say it's just a simple queuing system. Kafka is free and open source, but it requires a lot of efforts. Obviously, it's a lot of DIYs that you need to to do. And it's very flexible. It's got a SQL, query-based language for you to query the messages and all that. And for events polling, that's great. EventBridge, as I said, it works perfectly. It's desirable for applications that all reside in a single cloud, and though that they've been expanding to support some third-party systems. But the majority would be still the case where you have applications in a single cloud. It works really well if you have all of your applications within AWS ecosystem. But obviously, this retailer, they have a lot of, heterogeneity there across their technology landscape. They have a lot of multi-clouds there, different, some of them are SaaS solutions, some of them are on-prem, some of them are AWS and Azure. So EventBridge won't work there. And the big downside of EventBridge is ordering is not guaranteed. So that's a big no-no for them. And AWS EventBridge is very cost effective though. So actually it didn't touch the cost, but AWS EventBridge is actually very cost effective. For 1 million messages, it's only $1 really. So that's quite a cost effective. And Kafka is free and open source, but really the downside is there's a lot of customization and logic that you need to implement. Both Anypoint MQ and PubSub Plus are yearly subscription based. The pricing is not published, is not publicly available, but they charge a yearly subscription there. So yeah, that's pretty much it, what I need to cover today. And thank you all so much for your time and to watch my my talk today. If you have any questions, as I said at the beginning, please feel free to email me. My email was right at the beginning of this slide. I think it was the second slide. Thank you.